This is section 2.1 part 4, where we are going to classify and evaluate functions. When I say classify functions, I basically mean tell me whether the equation that you see represents a linear function, meaning it forms a straight line, or it doesn't represent a linear function, meaning it forms some other shape, whether it's a parabola or a V, something along those lines. Alright, so how do you know? Alright, just by looking at the equation, you should be able to tell if it's linear or not. So a linear function will always take the form y equals mx plus b. This is your slope-intercept form. Alright, and the big key here is we're always interested in the variable x. And the variable x should have an exponent of 1. Alright, here, alright, an exponent of 1, it's assumed, alright, because it's not there. Alright, so I'll make a little note here and say that the exponent is always 1. Alright, and if your exponent on your value of x is 1, alright, you should have a linear function in the problems you're going to see here. There is one exception though, and you'll see that down below here. Alright, so you know you don't have a linear function if your exponent on the variable x is not 1. Alright, here we see the variable is 1. Here, an example where you have the exponent not 1 would be y equals x squared. Or maybe y equals x cubed. You can see the exponent there is obviously not 1, so you know it's not going to be linear. Also, the variable is in absolute value bars. And when I say variable, I should write the variable x is in absolute value bars. So, here, an example might be y equals the absolute value of just simply x. Now, what's the exponent here? 1. But because it's in absolute value bars, we know it's not going to be linear. Absolute value actually forms a V shape. Alright, so if you have a graph absolute value, it will form a V, and we'll look at that later in this book. Another example you might see might be y equals the absolute value of x plus 5. So you have a whole expression inside the absolute value bars, but just as long as that variable is in there. Alright, the variable x inside the absolute value bars, automatically not linear. So after you classify the function, you're simply going to evaluate it with the given value of x. So we're going to see that down in the first problem. Alright, so our first problem is f of x. This is our function notation. Alright, f of x is our function notation, so f of x equals f of x equals 6x plus 1. Alright, so we're looking at this first, and we want to figure out, is this linear or not? Well, look at your exponent. That's 1. Do we have any absolute value bars? No. And we see it's in the y equals mx plus b form. So it looks like we do have a linear function. So yes, this is linear. So we've classified this problem. The last thing we have to do is evaluate it when x is negative 3. So function notation, alright, is going to look like this. F of negative 3 is equal to 6x plus 1. So essentially, when you have a number in the parentheses here, that's basically telling you what the value of the variable is. And our variable is x. So our value of x is what? 3. So I want to take this value of 3 and plug it in for x. So I'm going to evaluate this. Say, plug in my negative 3. 6 times negative 3 is going to give me negative 18. Plus 1, negative 18 plus 1 is negative 17. So I'm going to drop down my f of negative 3. And we can see f of negative 3 is equal to negative 17. Which means when x is negative 3, y equals negative 17. It's pretty much synonymous. Let's look at a second problem. Number 2. So f of x equals the absolute value of x plus 5. And then later we're going to look at f of 4. So the first thing we want to do is classify it. All right, is this linear or not linear? Well, I see absolute value here. All right, so those absolute value bars exist. All right, and the variable is inside the absolute value bars. So based on what we had written up above, all right, variable is in absolute value bars, we know this is not linear. So I'm going to first classify this as being not a linear function. And once I do that, now I can go on and evaluate the function for f of 4. So I've got f of 4 equals the absolute value of x plus 5. So I'm going to substitute in the value of 4 for x. So the absolute value of 4 plus 5. 4 plus 5 is 9. The absolute value of 9 is simply 9. So I'll drop down my f of 4. And we can see when x is 4, y equals 9. So f of 4 equals 9. Lastly, all right, we've got number 3, which is, we'll say g of x. Function notation doesn't always have to start with f. It can start with any letter. So we've got g of x equals x cubed plus 3x squared plus 100. And then we see f of negative 5. So we want to classify this as either being a linear function or not a linear function. And we notice the variable x has exponents that are not 1. So anytime you have an exponent on the variable x that's not 1, you know it's not a function. So we're going to classify this as not a linear function. So it's not a linear function. And now we want to evaluate it for f of negative 5, or not f. To be consistent, this should be g. Because I use g here, you will always have the same letter. So we want to classify it for g of negative 5 equals x cubed plus 3x squared plus 100. So I'm going to substitute the value of negative 5 in for x. So I've got negative 5 cubed plus 3 times negative 5 squared plus 100. So negative 5 cubed is negative 125 plus 3 times negative 5 squared, which is positive 25, plus 100. Order of operations tells me to do this multiplication here. So I've got negative 125 plus 3 times 25 is 75 plus 100. Now I add from left to right. So I've got negative 125 plus 75 gives me negative 50 plus 100 gives me positive 50. So I've got g of negative 5, drop that down, equals negative 50.